Create a 10 minutes video for YouTube about India's next leap, 30-Petaflop Supercomputer to power the future. Imagine a machine so powerful that it can simulate the human brain, predict monsoons weeks in advance, model nuclear reactions, and accelerate drug discovery, all at once. Now imagine that machine sitting right here in India. This isn't science fiction, it's India's next leap, a 30-petaflop supercomputer that's about to redefine how this country computes, innovates, and competes on the global stage. But before we jump into the future, let's rewind a bit. Because India's journey with supercomputing hasn't been easy or straightforward. You might remember the sudden national shutdown that rippled across industries not too long ago. A digital freeze that brought data centers, research networks, and even a few key government systems to a halt. For a few days, the country's digital heartbeat slowed down. Servers went dark, simulations were paused, research timelines slipped, and for a nation increasingly dependent on computation, that was a wake-up call. But what exactly was that shutdown? In simple terms, a shutdown is when large parts of a country's digital or computational infrastructure, like networks, servers, or research clusters, are temporarily taken offline, either intentionally or due to cascading failures. Sometimes it's for maintenance, sometimes for cybersecurity, and sometimes because the system itself can't keep up. In this case, the causes were layered: an overstrained data backbone, outdated hardware, and a series of cascading software faults triggered by an abrupt data migration. Think of it as a national blue screen of death. The impact? National weather forecasting models went offline for 48 hours. Genomic analysis pipelines used for public health monitoring were delayed. And several AI-driven defense simulations had to be manually recalibrated. For a digital economy the size of India's, that was more than just a glitch. It was a reminder that the country's ambitions were outpacing its infrastructure. And that's when the seeds of the new 30-petaflop supercomputer were sown. Now, for those who aren't familiar, petaflop stands for quadrillions of floating point operations per second. In simpler terms, it's a measure of how fast a computer can calculate. 1 petaflop means a computer can perform 1 quadrillion. That's a million billion calculations every single second. And 30 petaflops? That's like every person on Earth performing 4 million calculations per second simultaneously. This upcoming system will join the league of global high-performance machines, those that drive artificial intelligence, national defense, weather modeling, astrophysics, and climate research. And for India, this is more than just a technological milestone. It's a statement of intent. Because let's not forget, India's tryst with supercomputing began decades ago in the 1980s, when the US denied export of Cray supercomputers, citing security concerns. That setback gave birth to India's indigenous efforts under CDAC, the Center for Development of Advanced Computing. And out of that came Param, India's first supercomputer. From Param 8000 in 1991 to Param Siddhi AI in 2020, each generation has been a leap in power, sophistication, and autonomy. But this new machine, it's something different. It's not just an upgrade, it's an evolution. The 30-petaflop system, expected to be operational by late 2025, is designed with AI-accelerated architecture, indigenous hardware integration, and next-generation cooling and energy optimization. That means it won't just be powerful, it'll be efficient, sustainable, and adaptable for AI-heavy workloads. And here's where it gets even more interesting. This new machine will serve multiple sectors simultaneously, from weather and climate modeling, which affects everything from agriculture to aviation to drug discovery, where high-performance computing can reduce years of research into months. It'll even support national AI models, training large language systems and pattern recognition algorithms designed for Indian languages, datasets, and demographics. Essentially, this supercomputer isn't just a machine. It's a digital backbone for India's next decade of innovation. But if we zoom out a little, there's also a larger story here. The last shutdown taught us something fundamental. Dependence on fragmented systems and outdated computational clusters can make even the most digital nations vulnerable. When one node falls, others follow. When a network pauses, innovation pauses with it. The 30-Petaflop initiative is India's way of saying, never again. Never again will research stop because of bandwidth. Never again will progress pause because of outdated silicon. And never again will innovation wait for imports. Instead, this time, India is building the infrastructure from the ground up, combining indigenous design, open-source architecture, and collaborative research ecosystems that bring academia, government, and private industry under one computational roof. To put this in context, the 30-petaflop mark will place India among the top 30 fastest supercomputing nations globally, competing with the US, Japan, and China. And what's more, it's a stepping stone. Because under the National Supercomputing Mission, India's long-term goal is not 30, but 100 petaflops, and eventually, exascale computing. That's a billion calculations per second, a scale of computation so vast that it could simulate planetary systems or decode biological evolution in real time. But why does all this matter to the average person? Because the effects of such computing power ripple into everyday life. When your city gets accurate flood warnings, that's supercomputing. When a farmer gets early climate insights about next season's rainfall, that's supercomputing. When vaccines are designed faster, or satellite imagery is analyzed instantly for disaster relief, that's supercomputing. So while it may sound abstract, 30 petaflops isn't just a number. It's the silent force behind progress. And yet, there's also a philosophical layer to all this. The last shutdown showed that even in an age of automation and AI, resilience matters. Technology is powerful, but it's also fragile. Every system needs redundancy, backup, and adaptability, because power without stability is just potential, not progress. This time, India's approach is hybrid, combining local cloud infrastructure, quantum research nodes, and national data hubs connected through a unified backbone. Essentially, it's like creating a digital nervous system, one that can self-heal, reroute, and keep functioning even under strain. And if it succeeds, it could become a model for emerging digital nations, showing how computational sovereignty can coexist with global collaboration. So, the next time you hear about India's 30-petaflop supercomputer, don't think of it as just another piece of hardware. Think of it as a symbol of a country that learned from its failures, endured through shutdowns, and came back stronger with silicon, code, and vision. Because the story of technology isn't just about speed, it's about resilience. And India's next leap isn't just 30 petaflops of power, it's 1.4 billion minds moving forward together. Welcome to the next chapter. This is Beyond Binary, where every byte tells a story.